Okay, let's go over this problem. So in this problem, we don't have to go back and recalculate the resistance because they told us we've got this aluminum wire and the wire is cut in half. So if it's cut in half, what is the only thing that we've changed? The only thing that we've changed is length. So all we have to do is cut the resistance in half. So divide by 2. So here we have a light bulb with a resistance of 2.9 ohms. It's got a 1.5 volt battery connected to it. What rate is electrical energy transformed? Well, what is the rate of electrical energy? That is power. So we can do that with a straight up P equals V squared over R. Okay, in which electric circuit would the voltmeter read 10 volts? Well, remember that the voltage is going to be read by the voltmeter in parallel. So if we put this voltmeter around here, that's exactly the same as putting the voltmeter around like this, because it's going around the total. What's the total? The total is 10 volts. This one's kind of tricky. We've got 2 bar magnets and they want to know what the direction of the magnetic field is. Well, we have 2 magnetic fields. What's the direction of the magnetic field due to the south pole? It's going to be this direction. And what's the direction of the magnetic field due to this one? It's going to be down. So the sum of the forces are going to be the resultant of those 2. So that's going to be choice 3. This question is super common. So they first want us to draw a diagram of the circuit, and they tell us that the equivalent resistance is 5 ohms of 2 10 ohm resistors. Well, how's it possible to get an equivalent resistance that's lower than the individual resistors? The only way to do that is with a parallel circuit. So we draw a parallel circuit, and the proof of this, you didn't have to do this, but the proof is that if we do the formula for a parallel circuit, we get 5 ohms. In the next part of this, we have a circuit with a 100 and 200 ohm resistor in parallel. Calculate the equivalent resistance. So it's the same formula, and we just put these numbers in. Remember, x to the minus 1 plus x to the minus 1, and then we have to hit that x to the minus 1 one more time. So the next question is that we have they want the current in the 200 ohm resistor. Well, it's in parallel. And if it's in parallel and it's a 10 volt battery, then it's 10 volts in all of the different locations. So we can just throw 10 volts into V equals IR to get the current. And then the last question is to find the power dissipated in the 100 ohm resistor. Well, we know the resistance, and we also know the voltage is 10 volts in every resistor. So we can just do P equals V squared over R. Compared to the resistivity of a 0.4 meter length of 1 millimeter diameter copper wire at 0 degrees Celsius, the resistivity of a 0.8 meter length. So what did we change? What did we change? Well, we changed the length. But look at what the question is asking compared to the resistivity. So resistivity is not affected by length, so therefore the resistivity remains the same. And then this final question, we've got this 2 meter length copper wire is connected across a potential difference of 24 millivolts. They give us the current through the wire. And the same copper wire of the same temperature is then connected across a potential difference of 48 millivolts. So the resistance of the wire hasn't changed, and what have we changed? Well, we've doubled the current. And if we've doubled the voltage, and if we've doubled the voltage, then we will have doubled the current.